Okay.
We are going to talk about application of functions. That's the next one. Kind of a short section. I don't know how much we'll explain about this. Talk a little bit about it. Section 1.8, economic functions. So these are some important functions that we use in an economic context. We'll revisit talking about revenue, profit, and all that stuff that we've mentioned before. But right now we want to introduce two new and important functions that we will need to know about. So these are the supply and demand functions. So that's what we're going to talk about for a little bit. Let's actually define what these are. So these are functions that deal with the price of a certain product and the quantity of that product being produced. They both deal with those variables, but they do it so from a different perspective. So a supply function describes the amount of products a supplier. So we're talking about the person who's doing the manufacturing, the person who's making the product or building or offering a service. The amount of products a supplier is willing to produce at a certain price. So we could be producing a product and the person who is actually creating that product could make a decision to say, you know what, I'm not going to make this product for less than this price, right? So if you're going to pay me less than this price, I'm not even going to bother, I'm not even going to start, okay? So once the supplier actually sets the price at which they're willing to pay to actually produce a certain number of products, that's called and we describe that with a function, it's called the supply function. The demand function is actually from the point of view of the consumer. So a demand function describes the amount of products consumers are willing to purchase at a certain price. So that's it. So people themselves, the actual consumers, can also decide, well, I'm not going to buy a product if you're charging me this much, that's too expensive. Or as long as you're charging me this, I'll buy the product. Okay? And we'll talk a little bit more about how these guys work together, but we can introduce immediately something that's called the law of supply and demand. I don't know why they call it a law. It's really somewhat of an assumption. But it just seems to be an assumption that gets fulfilled most of the time in an economic context. It basically says, as price increases, so will supply. And as price increases, it's not exactly stated like this. There are multiple ways you could say it. Demand will decrease. Right? in terms of our mathematical vocabulary, we can say the supply function is an increasing function. The higher they can set the price, the more a supplier will be willing to produce. While the demand function is a decreasing function. So the higher people push the price, the less people are going to buy. And this is just a general assumption that would be made at a market in total. There are specific instances where this does not work. If you can somehow encourage people buying your product by what its reputation is, or maybe taking advantage of FOMO, you can actually get a lot of people to actually pay more for something than they otherwise would want to. But in general, the sentiment is that as the price of something increases, less people would want to buy it. No, as I said, specific, like there are like videos on YouTube where people just set up experiments and they'd be like, free hugs, and you know, the person would get a few hugs from people passing by on the street. But then if someone goes $1 hugs, they actually get more hugs. Like people believe, right? Once you can get people to believe that something is worth more, and so they'll pay more. But in general, if you raise the price of some product that people are already interested in, right? So you can have an iPhone. You know, back in the day, maybe it was like $300, and then you can raise it. You know, now it's like over $1,000 for an iPhone. I don't know where the ceiling is actually going to be, where people are going to be like, you know what, that's just too much. No more iPhone. But that's always a thing that they have to worry about, right? So the suppliers are always trying to inch up the price to see how much can we actually get away with. But eventually, people will actually stop buying something when it gets too expensive, because we have limited resources and we won't be able to stretch our money and get everything we want if the individual things we're buying is very expensive. So there's a general assumption called the law of supply and demand, whereas price increases, supply increases, but demand will decrease. Now, that is actually a very important thing. This assumption is made in Math 2009, meaning there will be situations where they will describe two functions. They will tell you that one is supply and one is demand, but they won't tell you which. And they'll have you try to figure out who is supply, who is demand, and answer this question based on your answer to that question. And the trick to doing that is to pretty much identify which of those functions is increasing and which is decreasing, right? So this is an assumption that we will be taking. So that's called the law of supply and demand. Now, supply, these deal with the same variables, so they can be confused. What I want to do is to talk about some clarifications, some differences. So when I say they use the same variables, I'm talking about something like P and X. So you usually see P is some function of X, or X is some function of P, where P is going to represent the price of something, and X is going to represent the number of quantities, number of items. So we can talk about, you know, P equals 5 minus X. There are cases where that might be interpreted as a demand function or a supply function, and you could figure out which, versus P equals, say, X minus 5. Now, based on what I've told you, if we're in a weird situation where a linear equation is a pretty good equation, which some situations are, which one of these would you think is the supply function, which is the demand function?
So would the supply function be P equals X minus 5, since it's increasing?
Right, so you look at this function, you'll notice that, hey, if I were to sketch that line, it's going to look like this, which means as the price is getting bigger, the number of products that the suppliers are willing to supply is getting larger, versus this one, where that's going down like that. So you would notice that here, as the price gets larger, people are less willing to buy, so that's decreasing. So without any other information, if these two functions were given to you, and they said one is supply and one is demand, use the demand function to do this, you'd immediately try to say, oh, well, this would be the demand function, and this will be the supply function, right? And it's going by this rule, right? We will always assume the supply function is increasing and the demand function is decreasing. And it can be confusing because they'll use the same variables and they'll list the same equations. In fact, that was on the quiz today, you might have noticed. And that's because they do ask questions like that, where I gave you two functions. And they had radicals in it, but it was p's and x's, and I said, identify which one is the demand, or identify which one is the supply. And that was the trick. If you sketch them, figure out who's going up as you move from left to right versus down as you move from left to right. Some differences here. So for one, this is always the assumed difference. We always assume law of supply and demand hold. So if nothing is indicated to you otherwise, that's where you're going to go. That's the first thing you're going to look for. Who is increasing, who is decreasing, and that's how you're going to make the distinction. Another way is sometimes supply, we'll use the variable s, uppercase S. So you might see them talk about, here's a function s of x, or s of p, or s of q, right? Once they use uppercase S to describe a function, chances are they're talking about a supply function. Right? There are not many other situations in Math 2009 where they use uppercase S for a function. That's not the supply function. The demand function will be, and this is even more common, and we'll talk about some examples now and in the future. The demand function is usually denoted with uppercase D. Right? So if you see a function, hey, they're talking about the function d of x, or the function d of p, or d of q, right? Q sometimes is used to represent quantity, right? But usually when they talk about these functions, uppercase S or uppercase D, they're talking about supply and demand respectively. Very rarely you'll see the depreciation function described by D, maybe uppercase or lowercase. You'll also see that described by V though. But uppercase S and D, usually supply and demand. And the question around, the context of the question itself would indicate to you which one they're talking about. So that's the supply and demand functions. So pretty much, supply describes how much a supplier is willing to produce at a certain price. So someone's like, okay, I'll pay you $10 if you could make this for me. Yeah, I really got the time, you know, got things to do, you know, I can't really produce it. Okay, fine, I'll pay you $50 if you can make one. I'll make you 3, you know, it'll be done by tomorrow. Usually when you raise the price, a supplier would want to make more because they have the opportunity to make more money, right, per item, right? And we'll talk about average cost. Whereas if you start inching the price up on your consumers, eventually they're going to be like, well, yeah, that's too expensive. So those are the important ideas. Okay. Let's talk about another idea, market equilibrium. So there's always this kind of tug of war between the supplier and the consumer, right? Pretty much a supplier wants to get away with the highest price they can charge, and the consumer wants to get away with the lowest price they can pay. So there's always this kind of back and forth. And how we kind of figure out where the solution, quote unquote, to this back and forth is described by market equilibrium. So this is the point of intersection between the supply and demand functions. So you could have a picture here. You can have one function like this, another function like that. Say we're talking about the price versus number of items. Who here would be the supply function?
The one up.
The one moving up. So that here would be supply, and this here will be demand. Now you'll notice that they meet at a certain point. This point where they meet is called the market equilibrium. This point here is called the market equilibrium. Right? So that describes, that is the price. Once, if you can discover that point, that's kind of the sweet spot, right? Because that's the price. This describes the price a producer is willing to produce and at the same time the consumer is willing to consume. So we're not going to talk about producer surplus and consumer surplus, but those things do come into play here. You'll see those in your economics class. But you realize that if you're on either side of this point, something is happening. If you're over here, what happens is the demand for a product is greater than the number of products currently in the market. So in general, here you'll have more people willing to buy than the suppliers are willing to produce. Versus on the other side, right, here when the price gets high, the suppliers are willing to produce a lot of products, but not many people are willing to buy those products. So that's not really good either, right? Here the supplier will have excess inventory. Here there'll be a shortage of the resource. However, there comes a sweet spot where both of these intersect. Your supplier is happy to produce that many products at that price, and the people consuming the product are willing to actually pay that price. So that's a very important thing. So this is called the market equilibrium. And it describes where the supply and demand functions meet, and the interpretation of that. This is the price where producers are willing to produce and consumers are willing to consume at the same time. So pretty much to find that price, you find the intersection of these two functions, which often means plugging one into the other or setting them equal to each other. So that you should know what that phrase means because it will show up. It did show up on the bonus to the test, and I think it showed up on the quiz. So, and you'll see this all the time. So a lot of times they'll talk about a function, supply and demand function, they'll ask you, where is the market equilibrium? Basically, all that means is find the intersection of the two functions. So sometimes you might have to figure out who's the supply function, who's the demand function. But ultimately, if you kind of find the intersection point, that would describe the market equilibrium. And that is something you'll be specifically asked for. So that's what that is. Now, let's revisit some old functions and rewrite them in terms of our new notation. So here's the thing. When considering the price, that an item is sold for, or can be sold for, can be reliably sold for. demand function is the one that's going to be used. Ultimately, when you're talking about the price that you can actually sell something for, it's going to be the price that people are willing to pay, right? So you can supply all the excess products you want, no one is going to pay you for it, and so you won't have an effective price. The price you can really think of, okay, this is the price of the product. It's the amount of money you can command for that product, right? So the demand function will actually be used as the price function a lot of the time. Okay? So now, when we look at things like cost, profit, revenue, etc. Right? And if we let the demand function equals d of x, where x is the number of items. Okay? So you realize that a lot of these formulas have a section in the formula for price. Right, so number of items. Right. So if we look at these guys, we can rewrite some formulas. Again, cost, it's not really any different here. Cost is going to be given. It still depends on the situation. There is no general structure or formula for figuring out the cost. It really depends on the situation. So that will always be given to you. Now, when it comes to things like revenue, we will tend to have some control over that. There are some general functions that we can think about. When it comes to revenue, though, remember, revenue is equal to cost, price, number of items sold times the price per item. So the number of items sold will be X, and the price per item, so we usually think of revenue as X times P. I want you to just be aware that we can also think of it as X times D of X. And this is to deal with a situation where maybe your price is not a constant. Right? So here, this is the demand function. Describing the price. That is, price is not fixed. You'll notice that in all the previous times when we were talking about revenue, the price was a certain price. I'd tell you, okay, we're selling the lemonade for $1.50 a cup, right? So that it's always $1.50. So you know that the revenue would just be $1.50 times X. But sometimes the price itself can actually change. So I can decide, if I analyze the market data, look at supply and demand functions, maybe keep a few statistics, I can decide, well, if I know I want to sell 10 cups, I would charge $1.50. But if I wanted to sell 15, I would charge $1.25. If I wanted to do this, once you give your price some nuance, some variability, the best way to describe it is with the demand function. Because at any given time, the amount of things you can sell will be determined by how much people are willing to pay for that, right? So you can know, I could get 15 people willing to pay $1.50 versus I can only get 10 people willing to pay $2. Right? So once your price becomes a variable, which is described by the market, we would instead of think of revenue as X times the demand function, right? And that's going to tell you the price that you're selling the product as, right? So not necessarily X times P, but X times the demand function. And there are times when they might tell you a supply and a demand function and then ask you about revenue, and you need to know, okay, I need to pick the demand function, which is going to be the decreasing one, multiply that by x, that's going to be revenue, and then we have to do this. So that's another way we can think of the revenue function here. It's just x times the demand function. So that's just a kind of new way you want to think about it. So you can think about x times p. If your price is just not changing, we're always charging this price. But if your price could change, which might be described by a function, and then you use that equation. Of course, profit will also change, because we know that profit is equal to revenue minus cost. So this is your cost function, c of x. And so this we could rewrite as x times the demand function minus the cost function. We can look at that as the profit function. So the difference between now and what we were doing before is that price was always considered fixed, right? In our problems that I was giving you, would always okay, the price is going to be this much money, and it's always going to be that much money, and it's assumed it's that throughout the entirety of the problem. Now we have a little bit of nuance. Now we're thinking of our consumers as reacting to the prices we're setting. You can have that. Another important function. This one is somewhat new. It was on the bonus of the test, and its name kind of tells you what it is. So if you just kind of remembered about what the average means. So a new function is the average cost function. This is denoted by c of x with a bar over it. That's kind of like a notation from statistics. Sometimes you put a bar over something to represent the mean of a certain variable. It is defined as, well, to find the average cost, what you do is you take the cost and divide it by the number of items sold. This tells you the cost on average. Just take an average, right? So this gives you the average cost per item. So I can buy 10 things and I spent $100. On average, I paid $10 per item that I bought. So that's the average cost. So tell me how much money you spent divided by how many things you got for it. That's on average per each thing would cost that much money. This is called the average cost. So there's nothing really much more to say about that. It's just that we want to measure the average. We just divide by the total number of things we have. That's kind of the mean cost, or the cost per item is what you can think about it. We'll talk a little bit more about that in the future as well, but for now just know the definition of that function. Let us now get into some examples. So the first example, I want you to determine whether the function is a demand or a supply function. This in and of itself is a question that could be asked. They'll give you a couple functions and they'll ask you, identify which one is the supply and demand. Let's do some examples. 1. Identify whether the given function is a supply or a demand function. A. So they're not always straight lines, they can be various curves, depending on what research would suggest, or what they just want to put on an exam. Okay, what about A? What do you think? Supply? Well, how do you sketch A? So it's a straight line. How would we sketch this line? Huh?
Because it's like a negative.
Going down.
Yeah, how would you plot it?
I put in like an x plus one,
Okay, that's taking too long. We spoke about plotting lines. What's the quickest way to plot a line? One problem with the test was I get the impression that a lot of people didn't get to spend a lot of time on part 2 because you guys were just doing a lot of things in part 1 the long way. What's the quickest way to get this? You don't need to put it in y equals mx plus b form.
Y-intercept.
Yeah, how would you do that?
So the y-intercept would be 12, so you would first plot 0, 12.
The y-intercept is not 12.
Oh, 12 over 5, so you gotta put it in y equals form?
Right, you plug in 1 equals 0 at a time. Plug in p equals 0, your x equals 12 over 5. So I can put it wherever, right? Plug in p equals 0, x equals 12 over 5. Plug in x equals 0, and at 12 over 2, sorry, which is 6. Plug in x equals 0, the p is 12 over 5. The line will pass through those 2 points. You'll notice that the slope is decreasing, therefore, supply or demand. The 3p minus 2x equals 8. Do the same thing here. Plug in x equals, if I plug p and x, and in general it doesn't matter who you put where, it'll be demand, it will be increasing or decreasing regardless of where you put the variables. I can plug in x equals 0, I would get my p is 8 over 3, that's a positive number. If I plug in p equals 0, my x will actually be minus 4, that will be over here. And so that line would pass through this, would continue with it. That is of course increasing, and so this is called supply. This makes me want to note something here. Now, I use the negative part of the axis to actually draw the graph, but of course, I just want you to note, we only consider the parts of these functions where both variables are positive. Right? Because you can't have negative price. You also can't have a negative number of products being produced. Okay, we produce negative 10 million iPhones this year. That's not a thing, right? So it's always going to be, you're always thinking of this part of the function. You kind of ignore that part, but you might use the negative part to figure out what the sketch would look like, right? But as far as we're concerned in the economics context, this is the only part of this function that you care about. This part over here and this part over here is not going to be, right? We won't consider that as existing. So, i.e., only the first quadrant is what we care about. Now, you might use a negative number to plot a point to figure out the graph, but once you've drawn the graph, just know that I'm only worrying about what's happening over here. C, supplier, C. Supplier demand.
Supply.
For this one?
Yeah.
Okay. What would the curve look like? Just look like. So I put X over here and P over here.
It'll be increasing. So the y-intercept will be 25 over 4 positive.
Right, so this one, yes, the y-intercept would be 25 over 4. For this one, it's a quadratic, so I probably would solve for one of these guys. We can solve for P. If I move this guy over, that would be 3 over 4x squared plus 25 over 4. So you know that's going to be the y-intercept. This here is an x squared, and it's a positive number, so I know how to draw that. That graph is going to look like this, right? Where the bottom is going to pass through 25 over 4. And of course, the only part of this function we care about is this part, right? We'd ignore the left part. So, in other words, if you were to sketch this as a supplier demand function, you would literally only sketch the right side. That would be the sketch, right? They'd ignore everything over here. So this is the sketch of the function. In this context. All right, whenever we're talking about the economic context, we ignore the negatives. Okay, so that's what that guy would look like. Now that is increasing, therefore, this is a supply function.
Wait, how did you get the 3 over 4?
Added 3x squared to both sides,
Oh, okay.
and then to solve for P, I divided by 4. So this is a supply function. Similarly here, if I were to solve for P, I would get minus 7x squared plus 13. I would divide both by 5. And so if I were to sketch that, this is an upside inverted parabola that hits at 13 over 5 and opens down. Right. So my sketch here would actually be look like that. You'll notice it is decreasing, therefore this is a demand function. So, for example, let's say on a single question, it was phrased something like this. The supply and demand functions for a certain product is given. Boom, they give you these two. And then they say, find the revenue when 5 products are sold, right? So that could be a question, right? What you would need to know is, okay, I can sketch these two very quickly. This is increasing, that's decreasing. That's my demand function, that's my price function. Therefore, the revenue function is going to be x times this, and then I'm going to plug in x equals 5. You see what I'm saying? Like that's what a complete, that's a very nice complete problem. That's a final type problem right there, right? So they won't necessarily identify which function is which. They'll say, here are 2 functions, there are supply and demand functions, find the revenue, right? You need to be able to identify who's the demand and multiply that by x, and that's your revenue function. And they might say, here are 2 functions, there are supply and demand functions, what is the profit when you sell this much? Well, again, you'd identify who's the demand, profit would be x times this minus some other cost function that they would give you, and then you plug in the value to that function. Let's move on to the next example. So identifying them is important because the other functions that they might ask about, revenue and profit and etc., might depend on you knowing which is which. And whenever they ask you about revenue and profit and all that stuff, the price function, what you'd use as the price, is always going to be the demand function. So you need to identify which is the demand function and know to use that. So let's do example 2. For each given pair, sketch them on the same axis. Now, in the final, you won't ever be asked to sketch something, of course, but knowing how to sketch them is important, so I've included it here. Because sometimes when you want to identify which function is which, a lot of times the quickest way to figure out which is which is to just sketch it, do a quick sketch, and that's how you figure it out. So I'm asking you to sketch them here, although maybe on a final or a test it wouldn't be required to. Identify the supply and demand on your sketch. Determine the revenue and the point of market equilibrium. So a kind of question that could be asked, as I said, is to give you, here's a supply and a demand function, not identifying which is which. Find the revenue, right? That could be the question. Now, the problem won't ask you to do this, but I would say you should be doing that anyway, because that's going to be the quickest way to answer the problem, right? So it's not, you're not going to be asked to sketch anything. They're just going to give you the function, figure out which is which, tell us the revenue, okay? In order to tell them the revenue, you need to know who's the demand. In order to know who's the demand, the quickest way is to see who is decreasing. In order to know who's decreasing, a quick sketch is a good way to do it. And so let me tell you the pairs. So there are only 2 parts of this question. And these are common types here. They will usually give you straight lines or quadratics or radicals. So we're actually going through, I haven't really seen them ask a question about another type of function. And B, we're going to do so these types of functions are pretty common. They can give you ones where the functions in questions are straight lines, or there's some kind of a radical expression, or they're quadratics. And the trick with the radical expression is to realize that they really sort of come from a quadratic, right? If you were to solve this and take the square root of both sides, they'd only care about the positive side. That's why you don't see the plus or minus. And so kind of the quadratic and these guys are very familiar. So that's a hint there. So they'll give you a pair of functions, they'll tell you their supply and demand, they might not identify which is which, and then they'll ask you something about it. Okay, so let's look at A. Okay, how do you sketch this? How do you sketch this one? Let's say I put X here and P here. How do you sketch this?
Y at 150.
The P is at 150, right? So if you plug in X equals 0, you can move the 300 over and divide by 2, so you know there's going to be a 150 here. And then,
negative 1/2.
and then what?
Negative
X is at 300.
X is at 300, I'm not sure what the negative one is. X is at 300, and so you have that guy.
But don't, when you move it on the side, you have to divide it by 2.
Move what on the side?
Like I had moved the X and the minus 300.
Yeah, we're not moving anything, we're finding 2 points. In order to sketch a line, you just need 2 points. I only care about finding the 2 points, I don't care about writing it in a nice form. It's not the point. The point is to sketch this really quickly, that's the point. To sketch a straight line really quickly, what you do is you plug in one variable equals 0 at a time, solve for the other guy. If I plug in x equals 0, solve for p, I get 150, put that here. Plug in p equals 0, solve for x, I get 300, put that here, connect it. You don't need to waste time actually solving for one variable or the other. And that's extra time that we don't have. On average, you have like 3 minutes per problem. You don't want to waste it on pointless arithmetic. If you look at this one now, the same idea. Notice that if I plug in p equals 0, I would actually get my x equals minus 200. So there will be a point over here. And if I plug in x equals 0, I would get p equals 200 over 8. Does that go into it?
25.
Huh?
25.
25, so it's actually lower here. So again, I don't care about this part of the curve, that's the negative part, but it's this part that I care about. Okay? So that's the picture. Now on this picture we can start to identify some things, right? So they can give you a pair of equations, they don't tell you who's who, but once you actually do this sketch, which you should be able to come up with in a few seconds because you're just plugging in points, you'd be able to identify, okay, this guy's the supply, this guy's the demand, this guy's the demand. And then you'd be able to say, this point is the market equilibrium. So now, that being said, we can do what they asked us for. So the question was to identify who's the supply and who's the demand. And so we get that this was the demand, this is the supply. And therefore, we can start to now talk about determine the revenue. So how would I find the revenue here?
So x times the demand function.
Right, so the revenue is going to be x times the demand function, where the demand function has to be in terms of x. At this point, I'd go about and solve things. So the demand function we just figured out was the top one. So that means we have 2p plus x minus 300 equals 0. We can get 300 minus x all over 2. And so this would mean that our revenue function is just going to be x times that. X times 300 minus x over 2. I mean, in general, that would be fine. If you want, you could simplify this more, but unless there's a reason to simplify, I probably wouldn't. So this would be x times 150 minus a half x, or I can write that as 150x minus 1/2 x squared. Now clearly they could ask you other questions like, what is the maximum revenue? Then you would notice that, hey, that's a quadratic upside down, just find the vertex. Then it says determine the point of market equilibrium. Let's actually find the specific point. This might be something you would have to do. It could also come in the calculator section where you'd have your calculator to help you. But as an idea, let's look how we actually do this. So I think I showed you guys how to solve simultaneous equations. I did do that. So you can do that as well. So you can plug this into your TI-89. It would be like solve, open parentheses, you type this out, comma, type this out, comma, you put in curly brackets x comma p to tell it to solve for x and p, and it will actually solve it for you. But another way to do it, if you, let's say we have to do it by hand, is find market equilibrium. So if we have 2p plus x minus 300 equals 0, 8p minus x minus 200 equals 0. Okay, so if you were solving this by hand, how would you do it? What's the quickest way? What's the first thing you see? What would you do?
Cancel the x.
Cancel the x by subtracting.
Addition.
By adding, right? By the way this is set up, it's just begging for us to use elimination or solving systems of equations by addition. If I add these two equations, notice that plus x and minus x will actually die. So I have 2p plus 8p, that's 10p. This plus that will be 0. This plus that will be minus 500 equals 0. So this means that our p would actually be at 50. Okay? So this point actually occurs when the p is 50. Okay. So the question could say something like this. Here's a supply and a demand function. Find the price for market equilibrium. Meaning if a supplier wanted to make sure that they could virtually sell out 100% of the thing they're going to produce, what price would they sell it at? It would be the market equilibrium price. Right? So they could say, okay, here are some two functions, supply and demand, they're not telling you which. Find the point of market equilibrium. Find the price that gives you market equilibrium. Right? That would be $50. They could have also phrased it as find the number of items they need to sell to achieve market equilibrium. And in that case, you're solving for the x. But right here we have the p. Once we have the p, we can go to any one of these and find the x. So I would just maybe use the first one. 2 times 50 plus x minus 300 equals 0. That's 100 minus, so your x would be 200. So point of market equilibrium. I'm writing it in the order x comma p, so that's going to be 200 comma 50. So that tells you we achieve market equilibrium if we set the price to be $50 and we would expect consumers to consume 200 products at that price. Yeah, so this question touches on a lot of bases. As I said, like a final or a test, you probably won't be asked to do all of this for a single problem, but they might ask you one or the other. So I just want you to see a bunch of things that you can ask for. Again, they could also ask you about profit here. They could ask you about maximum revenue, right? So all the kind of things that we were asking you before about functions, we can ask you any of those things now, right? So you can't really forget anything that I tell you. You have to just always remember everything. Okay, let's look at B. Now, usually when a problem like B shows up, they're really not that difficult, but the square root tends to scare people. However, usually if they put a square root in a problem like this, the square root function is going to be a pretty easy function to sketch. It's pretty much going to be like a shift, right? So they're going to pretty much take a square root function, they're going to shift it either to the left or right. And that's going to be the sketch. So don't get freaked out by the fact that there's a square root there, right? Just remember your training grasshoppers, and everything will be fine. A lot of you forgot your training on the test. I'll talk about that in a bit. the same one, we're going to sketch them on the same axes, identify supply and demand, find the revenue and the point of market equilibrium. So, let's look at the first one. I'm gonna use different colors. So, let's talk about this is the first function. And this is the second one. Okay, let's focus on the green one. Let's draw the green one. Put x here and p here. What would that look like? The square root of x plus 14. Oh.
Minus 14.
It will hit minus 14 where?
In x-axis.
And how would it look? Like this?
Yeah.
No. Like what? Right, like that. It would look like a square root. So again, don't care about this side, and it will continue like that. Why? Because we know what square root of x looks like. We should. It looks like that. Putting it plus 14 means a shift to the left. Right? That was transformations of functions. We looked at that last time. So they pretty much took this picture, moved it to the left. That's your picture. Okay. I wanted to draw that. So that would be the sketch of the first one. And again, we don't care about the negative sign necessarily. So this will just be something that's increasing like this, like a bulge. And what about this one? Where? And goes like this?
No.
It actually goes the other way. It'll go like this. Right. Now it will continue, but you don't actually care. Now, there. Right? Why? Because what we looked at was you start out with radical x. If you change it to minus x, remember the little transformation of function says if you place all x as minus x, it flips it. So if you look at y equals minus x, that guy looks like this. And then what we did was we moved it 36 units. So ultimately it looks like that. And we can identify here's the point of market equilibrium. And we can also identify the fact that the green one is the supply and the blue one is the demand. Okay. Now given that, how would I find the revenue? It would be what? That would be your revenue function. It's going to be x times the demand function, which we've now identified who the demand function is. It's the blue one. Now that's not one that we know how to deal with yet. In terms of if someone asks you to find the maximum or minimum revenue, that one's kind of challenging to deal with. But with calculus we can deal with it pretty easy. The last one was a quadratic and that was easy to do, just use the vertex. What about, what did I ask you about? Point for market equilibrium. Okay, how are we gonna find that?
Since both these are isolated, both equate
Yeah.
to each other.
P equals this, P equals that. We want the P's to be the same in each, so we just set these equal. So we have the square root of x plus 14 equals to the square root of 36 minus x. How would you solve that?
Square both sides.
Square both sides. Then
Put the two x's together.
Right.
and
move this x over here, you would get 2x. Move the 14 over there, you would get what?
22.
2. So that means your x would be 11. Now, and again, you can use either one of these to figure out the p. This implies your p would be, let's say I use the first one, just because. So it's 11 plus 14, that would give us what, 25, which is 5. So point of market equilibrium is going to be x is 11 and the price is 25. So the equilibrium price here is $5 and consumers will consume 11 products at that price. Okay, now the last example is not so bad. This one's just on average cost. The problems on average cost usually aren't very bad. So they tell you about the total cost to do something. So this is 3. Total cost to produce X item, cost is given by this function. What is the minimum average cost per item? So how do you go about doing that?
Factor x out.
No, they're asking us about average cost. What does that mean?
Divide the cost function on
Right, so I need to first divide this guy by x. So my average cost function is that guy. So I believe in the test or something I asked you guys about, find the average cost of 10 items or something like that. And you would have just divided the function I gave you by x and plug in x equals 10. Yeah, so that is the guy. What do you notice about that guy? What kind of function is it? It's a quadratic. Does it open up or down? It opens up. So this guy actually looks like that. So seeing that they asked us about the minimum, I know that they want this point here. That's the minimum. That's going to be the vertex in this case. And so now I would simply find the minimum average cost. This implies my x would be minus b over 2a. That's what? 6. This is another thing that issue that happened on the test. People not reading correctly what they were asked for. So here, I want you to appreciate that x is not the answer to the question. They asked us about the minimum cost, not the number of items. X is the number of items here. So you be very careful. And you have to read. The question will always ask you there are 2 variables in play here. There's the cost and the number of items. They're going to ask you for one of them. You need to know which. And on a multiple choice question, a very easy way to trip people up is to just put the answer for the one that if people weren't paying attention would have solved for and think that's the answer, right? So now that is the number of items. This is not what we were asked for. What we were asked for was the minimum average cost. So to find that, I need to go plug in that number of items into the average cost function. This implies min c bar is going to be equal to this guy, and plug in 6. So now, this is also 36. So I have 3 36s minus 6 36s, so I have minus 3 36s plus 200. And what's 3 times 36? Is that 108?
Yeah.
This is minus 108 plus 200.
92.
Huh?
92?
92. So that would be the answer. Now, if I were writing a multiple choice, I would put 6 as one of the answer choices to catch the people not paying attention, which is exactly how your final would be written. Right? So it's very important that you can know your stuff, but if you're not paying attention to what specifically you should be giving them, you can end up in a lot of trouble. And again, the final is multiple choice. So ultimately, there's no real partial credit on the final either. It's another reason why I don't put partial credit on the quizzes. I want you to get used to the idea of not having partial credit. So on the final, it's multiple choice. They're definitely going to put where parts of the answer on the way to the actual answer, they'll put these key numbers there. So in case you just, oh, that's the number right there, and you prematurely start shading in, you have to be very careful. Read, pay attention. So 92 would be the answer here. And that actually ends the section. That's 100. So, and this actually ends the pre-calc part of the course. We are going to start calculus after the break. Super excited. I'm not showing it. It's been a long week, very tired, but super excited to finally start calculus. We're going to start with limits after the break. What I will do now is give you back the tests. Okay, so yeah, the tests weren't as good. Well, yeah, most of them were bad, to be honest. But the thing is, most of them were bad for silly reasons. I mean, I started writing down some mistakes. Eventually, I just gave up because if anyone is curious to know the mistakes that showed up, rewatch my videos, and wherever I wrote something in red that says, here's a common mistake, avoid doing this. Multiple people did that. Most people did those kinds of things. Okay, so those are exactly the same mistakes. Exactly the ones I warned you before. I didn't see any other mistake other than those mistakes. So that was the first thing. So you would kind of think, someone not in the class would think that I was literally telling you guys to do these things that I was not telling you guys. The instruction would have been thought of as being in the opposite way. Because exactly the thing that I said, don't do this. Remember, don't do that. Let me write it in red. This is a common mistake. Don't do this. Sometimes out of the entire class, like 2 people didn't do such a thing, and it was so crazy. Okay. So that's one of the things. So at one point, in one sense, the first test, the grade is usually not the best out of all the tests, because it takes students a while to get in the groove. They're getting used to taking quizzes, they didn't take a test. But this one bothered me because of the nature of the mistakes that were made. It's pretty much all the things I emphasize not doing. One thing I'm not sure I super emphasize because I just didn't expect it, but there was a domain problem. So let me just talk a little bit about this, because I didn't expect people to get this wrong, to be honest. Here's a domain problem. So it says find the domain of this function. I think this was the function in version B. Okay. The array of answers I saw to that question was very disturbing. Anyway, how would you find the domain of this function?
Say at the top and the bottom equals 0.
No.
First.
How do you find the domain of this function? Yes.
I just put factor the bottom and
Why would you factor the bottom?
to find the 0 to see what like
it cannot be equal to 0, or else it will be undefined,
Okay, so pretty much the answer is to set the denominator equals 0. You don't care about the numerator.
And factor the domain.
Right, and solve for x, you'll get x equals plus or minus 3. The domain is everything other than that. That was the entire problem. Maybe 2 people got this question correct out of the whole class. That's it. So now for you to just say domain of f is to say all x except plus or minus 3. That was the problem. You would get 5 points for doing that. Most people got this wrong. What was going through your heads? I don't understand. I had people setting up inequalities, this is greater than 0. I had people trying to simplify and cancel stuff. I had people saying the top equals 0 and then using the solutions of the top equals 0 to down here. What are you guys? I don't understand why this seemed like a freebie to me, but apparently it wasn't. Right? Another thing, some people kind of got to this answer, some people forgot the minus 3. But then they went to try to write it down in interval notation. What would the interval notation look like for this?
Is it just a bracket 3? Wait, wait.
Isn't it the union, like, so the.
It's going to be a
parentheses,
union, but what is the
negative,
union?
Negative infinity to negative 3, parentheses, union, parentheses 3, 3, comma, infinity, and then yeah. So if you wrote that, then it was
No.
correct too, or no?
No, that's not correct.
a bracket.
So
A
after the
bracket
first
for
union
3
symbol,
because it's not included.
Right, so
Oh, well, okay, because I remember this, but if you wrote it in interval notation and the interval notation was right, did you get the correct answer, or you had to write like that, or did it matter?
not many people got it right, so I wouldn't say, I gave partial credit. So each problem was worth 5 points. So maybe if you mentioned, if at some point I saw plus or minus 3, I would have maybe gave you
Wait,
2 or
I
3 points.
remember what I did.
But, right, so when you look at everything except plus or minus 3, and as I always told you guys in domains, you probably want to sketch it so you're not missing anything, but no one did. Okay, so here you have these 2 numbers, meaning you cannot touch this number and you cannot touch this number, but you want to notice that you can touch anything else. So you can touch anything on this side, you can touch anything in between them, and you can touch anything on that side. It's just these 2 isolated numbers themselves. And therefore, you would have an interval for each of these. On this side, it's the minus infinity to minus 3. In the middle, we can touch. That is minus 3 to 3. And over here, we can touch. That's 3 to infinity. A lot of people miss the middle one.
Wait, why would it be the bracket?
Because if you have brackets, that means it's included. To put a bracket here means you can pick minus 3 itself as one of the values, but however, you can't. Minus 3 right here will create a 0 in the denominator. So you definitely want open parentheses everywhere. So I had 2, maybe 3 people getting this right. Out of all the others, half of them could get here but missed the middle part, and the other half just did something else completely. Like I'm wondering, like who told you to do this? And at this point, it's like this is something that you should have known to do before this class. So the fact that I actually covered it in this class, again, it was very strange. I had questions where I was asking about a quadratic, and people were using the formula for the slope of a straight line. That happened. Why? How? I don't know. But there were questions asking about quadratics that are like, y2 minus y1 over x2 minus... What are you talking about? That is for a straight line. And it's a quadratic that the question is asking about. Piecewise functions. People didn't know how to deal with piecewise functions. So there was a problem. where f was defined to be a piecewise function 2 plus 3x squared, x is less than minus 1, 7. This was a strict inequality. I think this one like 2x squared or maybe x squared. That doesn't matter. Okay, so now I ask you, what is f of 0?
7.
Done, that was it, 5 points. 2 people maybe got that right? I had people plugging in 0 into all of these and then adding the answers at the end. I had all sorts of things. I had people tell me, oh, the answer can't be determined. Like, we can't figure this out. It's an unsolvable problem. I had people tell me all sorts of things. This says x equals 0. All you need to do when a piecewise function is figure out which line applies to the value that you're given. X equals 0 falls into this category because 0 happens to be between minus 1 and 3. Therefore, ignore everyone else. Your answer is right there. I had some people like working this out. I don't understand what happened because a lot of it was like mess all over the place, which I don't know why there was. There's nothing to plug in. It was just 7. The answer is right there. And I had ended up seeing people derive the fact that, I don't know, minus 9 is greater than 2 or something like that. And they actually box that as the answer, some people. Are you looking at what you're writing down?
What?
Like, are you paying attention? Like, forget like when you write down the answer, do you realize what you're saying? Minus 9 is bigger than 2. Like, that should be, I don't know, there was all sorts of, I don't know if it was, the common mistake, I saw this a bunch of times, the one that I specified never to do. When computing the difference quotient. Okay. Tell me how to compute f of x plus h.
Plug in whenever you see x with x plus h.
Yes. Everyone should have that. Notice that I didn't have to tell you what function I'm talking about to ask you how to do this, right? Because you do all of them the same way. You need to have in your head f of x plus h means everywhere I see an x, put x plus h. A bunch of people just wrote down the function and then put an h at the end. Like they wrote f of x and they put a plus h, right? Something that I've said over and over, they're not the same. This is not the same as f of x plus h. Because this one says, take f of x, add h to it. This one says, everywhere you see an x, replace it with x plus h. These are two very different things. I had a lot of people doing this thing when they should have been doing that thing. When I specifically said, look out for this, common mistake, I wrote it in red. A lot of people copied on the same thing and put a plus h, and then every time I did a problem like this, we did a lot of problems like this. And I would turn to the class and I would say, okay, so what is f of x plus h? I asked that like 50 times. I don't know, a lot. I asked it a lot of times, and people still don't know how to do it. Other than that, I mean, I just stopped, after a while I just couldn't take anymore. I stopped writing down the mistakes, but there were some wild ones out there. But the other overall impression that I got was, as I said, a lot of people didn't get a lot of time on part 2, because I saw like blanks, like 2 or 3 blanks was on average on part 2. And not understanding these ideas is why, because I'd see people with this, and they're like calculating all this stuff, going into another question. I'm like, how much time did you spend doing that, right? When the answer was just right there, sitting, staring at you in the face, right? 0 falls in this line, 7 is the answer. It was supposed to be a 10-second question, and you move on, right? But I got the impression that a lot of people ran out of time on part 2 because they were spending too much time on part one, and it's because they ignored everything I said when I wrote in red. Maybe I should stop writing things in red, I don't know. Maybe that's the problem. Because everything I wrote in red, common mistake, don't do this. It was done with wanton abandon. And it was, yeah, a little bit discouraging. I had some rays of sunshine. I had some people get in the 90s and 80s, and someone even got over 100, and with points to spare. But the majority didn't do so well, and they didn't do well because of silliness like this. It's not like it was, the kind of mistakes were weird. You know what I mean? It's not like I can say, okay, you kind of know what you're doing, you're just a little bit sloppy here. No, it's like you have no idea what you're doing. Why would you do that when I specifically said it? Why do you not know how to find the domain of a rational function? Set the denominator equal to 0, solve for the answers, avoid everyone else. Some of them I just don't know. There was no real excuse. And some of them it was hard to actually say, oh, maybe they didn't understand what I taught, because a lot of it you should have known before even being here. Like domain is something you should know how to find. I mean, I reminded you how to do them as a courtesy. It wasn't meant to be a part of what we're doing. So that being said, so what I want you guys to do, okay, so the test is up on Blackboard. Here is what you will do. So test, maybe I should write it in red, everyone will ignore me. No one's gonna do it. Okay. Here's what it is do. Test 1 and solutions are up on Blackboard. Step 1, do not look at the solutions. That needs to be earned. Okay, what you will do is you will go over your version of the test. Okay, so there are two versions, version A and version B. I want you to go over your version, right? So I give you version A, you're going to go over version A in the sense that print out the blank version. Redo it. Somewhat pay attention to the time, but I don't even really care about paying attention to the time that much here, really. Just redo it. If it takes you 3 hours, get it done. I want you to go through the blank version of the version you took. Go through the blank version, do everything, right? So you're not under any pressure, right? So you're gonna know how you think when you're calm, right? That's the basis for something. Do all you can, and do not get help. Do not ask anyone to help you. Do not look in your notes. Pretend it's a test except for the time. That's pretty much what you're gonna do. No help. Okay? Don't do it in a study group. This is something you're going to do by yourself, completely by yourself, with only what you could have in a test. So on the first part, don't use a calculator. On the second part, you can use a calculator, but no notes, etc. You will go through, right? That's going to tell you a lot of information that a tutor can use to help you. Okay, so that's the first thing you're going to do. You're going to go over your version. You're going to then go over your version with notes. Okay? So on the second part, you're again going to go over this test. The things you left blank or you kind of feel about, right? Print out another version of the test, go over those problems. Okay? What that's going to tell you is, are the notes helping you? Are you understanding what you're reading? Do things need to be rephrased in a certain way? That's what that's going to figure out. So this is going to kind of tell you where your basic knowledge is. This is going to kind of explain why that is your basic knowledge. Maybe there are just some definitions you just didn't know. If there's a problem that you read the notes for that problem and you still don't know how to do it, that's something you need to know is occurring, right? The fact that there's a definition, but even when I read the definition, I don't understand how to do this. That's a problem that a tutor needs to help you with. very seriously. So go over it by yourself, no help. Go over it again with your notes based on, just look through your notes. Maybe you can even look through a couple examples, but nothing too crazy. You want to go over that too, because that's going to tell you, this will tell you what you understand. This will tell you how you're comprehending what is being done in class, okay? You're going to go over again with a tutor. Now I know this sounds extreme, but for some of you it's needed. Like, this is what it's going to take. Right? We're still in the same version here, your version, right? Go over by yourself, no pressure, but no aids either. Go over what you've missed from that with your notes. You do not want to confuse these two. So make sure you know, if you did a problem using your notes, you make a note of that, like I did this using notes, right? You need to identify these two different situations. You're going to go over again with a tutor. You're going to talk about the issues. You're going to talk about the fact, you know what, even when I looked at my notes, I didn't understand what to do here. Can you explain it another way? Maybe there's some key insight that I'm missing. Can you go over that? Or right here, the first time you go to the version, the tutor will be able to say, okay, you have this issue. You always add an H when you should be replacing all X's with X plus H. You need to look out for that. Or you always drop a negative sign, or you're bad at negative sign. Maybe you need to look over quadratics. A tutor can tell you basically the skills that you're missing by looking at this version of what you went over. In terms of the key insights that are causing you to make those mistakes, the tutor will figure out by this version of the things you're doing, right? And that's where, at this point, the advice isn't going to be, well, just memorize this formula. It's going to be like, here's what the concept means. It's a concept issue. You're missing a concept. It's not about the calculations. You're good with the calculations once you know what to do, where to put the numbers, but you need to go over the concepts. The tutor is going to help you with that. Or you can see me during office hours, and I can help you with that. But you need the data to go with that. It's not good enough to just go, I did bad on this test, help me with it. That's bad. It is also bad to just go straight to the answer. Oh, I got this wrong, what was the answer? That is bad. Students who are at the B level, A minus level, and they just want that little bump to figure out, oh, I made a sloppy mistake, what should I have done? Students like that could look at the answers. If you're getting a D or an F on a test, that is the wrong thing to do. It is the wrong way to study. You are going to trick yourself. You're going to read the solutions, and it's going to seem like it's going to make sense, and you're going to tell yourself you know what you're doing. You do not, I guarantee it. You would not know what you're doing. Do not look at the solutions until you've gone through this process. You should go over the version you're doing 3 times. 1, no help whatsoever. 2, go over with your notes. This will identify skills you're missing. This will identify concepts you're missing. 3, you need to fill the gaps that you've identified from those 2 rounds with a tutor. Of course, the idea being, if you couldn't figure it out by yourself with your notes, you probably need outside help. That should be something that's obvious at this point. So anything that you couldn't figure out by the time you got to this step, you need to see another person external to yourself to go over that concept with, okay? Now you are going to fill in all those gaps with that person, someone who knows what they're doing, okay? You are still not allowed to look at the answers, right? Now your tutor may view the answers at this point. And maybe you'll have people who are pretty good, but maybe they're a little rusty and they want to see my solutions too. Oh yeah, okay, and get it. So your tutor can view the answers. Okay. So this is all with the version that you have done. These 3 things would happen. Now, go over the other version. Right? So if you did version A, you are now going to print out the plan for version B. Do under test conditions. Right now, you are going to put the pressure on. Okay? Before, this should be a no pressure situation up to here, right? This is just you doing recon. You're finding out information. You're doing some research on yourself. What do I understand? Where are my holes? Where are my gaps? Can I find someone to explain them to me and figure things out? Okay, so you should feel pretty confident that, okay, I've gone through this test like 3 times now. They explained my gaps. I feel pretty confident. I think I got it. Once you have that feeling, you do this. Go over the other version and really put the pressure on. Put on the clock and do it. Okay? And afterwards, check answers. At this point, you can look at the solutions. Before this point, you are not allowed to look at the solutions. And people who go through this process, by the time they get here, will usually be in pretty good shape. Okay? Now, some of these might take a bit long time. I mean, depending on how these goes, you might have to have like a hefty tutoring session to get over that. But it's going to be worth the work that you put in. The thing is, once you kind of figure out the right way to do something, it might take you a long time the first time, but it gets better and better over time, right? The more you do this, the more efficient you get at this process. You'll start to know how to check your work. You start to know when you understand something versus you understand the written solution, because those two things are different. A lot of times you might see me here writing on the board, and you might think, oh yeah, well that's easy, I got it. It's very different when there's a blank page and there's only you and no Jhevon. It's a very different thing. Your brain thinks of it differently, right? So at this point, check your answers, and if bad after this, I would probably identify bad as less than 70. Okay? I mean, if you did really bad, you got like a 20 or a 30, don't expect you're going to jump to 100 after studying one time the proper way. It's a journey, right? You try to bump yourself up, get a 70 this time, try to get an 80 next time, try to get a 95 the next time. It's a process, right? So if bad after this, see Jhevon. Jhevon could also be substituted for tutor. Because a lot of times it takes a tutor with a lot of experience to really figure out why a mistake would occur. Sometimes it's easy to see a mistake, but to say why someone would make that mistake, that's a little bit more subtle. Right? You need a really good tutor to be able to do that usually. Yeah, so that's kind of the process. That's how you're going to start to work your way back. And the hope is by the time test 2 comes around, you're going to be in much better shape. One other thing I would just say, like in general from now on, just pay attention. Right? You'll be surprised how far that goes. Right? If I write something on the board on red, pay attention to that thing. Right? Don't just copy down your notes, okay, let's just go do. No, you're studying for a test, go back over your notes, everything Jhevon said don't do, highlight it, make sure you know, okay, never do that. That's it. You'll solve so many of your problems just by paying attention. You'll be surprised. Right? It's an amazingly effective strategy, right? That enough people don't do, right? But that's kind of going to be the game plan. I will give the tests back. We will also take, after this, I guess, a 15-minute break, and then we'll actually start some calculus. So that would be nice.